Okay, so I think we'll get started. It's about time, and first want to say thank you for coming to my presentation. I know there's some very interesting ones going on right now, so I appreciate you being here. And hopefully, like the slide here, that's how you guys feel at the end of the show. So at the end of my talk. So what I want to cover today is sort of around the area of boosting documents beyond just relevance. So what we'll specifically look at is recency boost, boosting by popularity, and also not quite boosting, but sort of in the same area is filtering documents based off of user preferences. So those are the things I want to kind of hit on. The one thing I want you to come away with this, if you only come away with one thing, is that Solr is very powerful in terms of boosting and influencing the scores of documents. With that power comes some responsibility on your part. You can do bad things with these boost features, and like the people we see here, we're all after users being happy. Hopefully, these people are looking at one of your search solutions, and that's what we're all striving for. So come away with the fact that the power is there. It may take some tweaking and some experimentation, which we'll go into. Okay, so just briefly, my background. On the handout they gave you, it says I'm with the National Renewable Energy Lab, which is true. They are not sponsoring my talk here today. The areas I sort of focus on are big data, and that's what I'm doing for the lab. But one of my other passions is search and machine learning. So I've been doing Lucene-based solutions for about 5 years and started sort of in the Solr area last couple years. Mostly I cut my teeth in Solr on a mobile app for magazine content, and I'll talk a little bit more about that. And that was a recommendation engine and a search engine built on Solr, Mahout, and Hadoop. I've also dabbled in migrating fast solutions to Solr for a real estate portal, and then on the side, kind of my own special project, I'm building a wine search and recommendation engine called VinWiki. So are there any, and I should mention, I actually like to kind of call out just random questions to the audience, so it makes it a lot easier on me if somebody responds, even if it's a lie. But so anybody out there actually migrating from fast to Solr at this point? Okay, all right, good. Going to be. So this is supposed to be sort of an intermediate level talk. If you need me to go deeper, I'm happy to, or if I've sort of assumed too much, let me know that as well. Okay, so the first one I want to talk about is boosting documents by age, and the good news is we can just descending sort the results by the age and be done, right? That was sort of rhetorical. Otherwise, we wouldn't have to be here. The idea is basically that newer content, all other things being equal, is probably better than older content in a lot of cases, especially web and business documents and those type of things. If we're doing a library search, that's probably not the case. So that's kind of my first lesson that I want to talk about is this is not a one-size-fits-all, but it is something you want to kind of have in your bag of tricks as a Solr user. I think it's useful for news. I mentioned magazines. Business docs, probably that's more of a gray area, and we'll see how we can actually adjust the boost around that idea. And then also local search, which is actually kind of how I came about having to solve this problem in my search problems is in the magazine world, probably like a lot of Solr users, I threw in DisMax and maybe boosted the title, and bam, I had a search solution, and it was great, right? Solr has a great out-of-the-box experience. The problem is, for a lot of queries, people would type in these really relevant old articles would just keep popping up on the first page, And my customers, the publishers, were like, well, we really want to showcase our newer work, but it still has to be relevant. So. And where we really hit this was in local search. Things, when you're searching for things related to kind of where you are and where you live and those type of things, really newer content is better. So I had to kind of take this problem on, and the solution I came up with has evolved over time, and actually it's a little bit of a, say, exaggeration to say that I've really improved upon Solr, because Solr has improved itself in this area quite a bit over the last year. So when dealing with document age, there are indexing concerns. And the main one is you basically have to store something that allows you to calculate the document's age. Right? And very simply, it can be a date, so such as the published date. Maybe not as good would be the date it comes into the index. That's dangerous. If you re-index, you have to keep track of that. So, but let's just keep it simple and say it's a date. In the Solr world, if we want to do things like boosting and filtering and sorting, the date has to be of special type, and that's why I'm showing the field type here, tDate. This is a tree date field. It basically has a numeric representation of your date and is great for doing things like range queries. How many people out there actually did training this week? Oh, wow, excellent. Okay, did you learn about tree fields in training? Little bit, okay. Good, all right. So the thing we need to know is document age is represented by a tree date field. And then some of these other things, just since there are a lot of people that went to training, who can tell me what omit norms true does? And this is not meant to, if anybody knows off the top of their head, okay. What it does is it basically says norms are typically for long text fields, so that short documents kind of get a natural boost above long documents. You don't need that for things like dates, so you want to admit that. So one thing I want to mention about the date is, notice down at the bottom I kind of have a note there, and that's more of a tip to myself to remember to think of this, is that you don't exactly have to store your dates with millisecond precision in the index. Right? Because if you do, you have a whole lot of unique terms in that field in your index. For something like the published on date, does it really matter what second it was published on or what minute? Maybe if you're doing real-time sort of Twitter-type search, it probably does matter. But in my case, with articles and news and things, our precision was good enough. So the one thing you'll notice is that you have to, on the indexing side, round your dates down to like the nearest hour or minute or what have you. Unfortunately, that's not in Solr yet. I think it's planned, and there's a ticket out there to do it, to make it very easy to kind of specify the date precision on the indexing side. But for now, you have to do it yourself, and as you can see with the code, it's very simple. Okay, so probably in training, you learned about function queries, I hope. Bottom line, function query basically calculates a value at runtime for each document in the results. And that is useful for ranking and sorting. Okay, so we can, and I've listed here not a comprehensive set of the built-in Solr functions. As you can see, there are quite a bit. Off to the right there, you'll notice there are actually some related to sort of geospatial type search things, such as the Haversine formula for calculating distance between 2 points, things like that. So we're going to make use of the ones in red there, the reciprocal function, the min, and the millisecond function. Okay, so let's get into it. There are solutions out there for freshness and recency boost that are index time boost, but in general, and if you didn't learn this in training, in general you want to lean towards a query time boost because it's easier to tune. You don't have to re-index, right, to tune your query side, but if you have an index-based boost, you have to re-index if you want to tweak it. So we're going to look at a query time boost solution for this date problem. And the syntax there essentially is pretty exotic, so I'll let you kind of digest that for a second. And what it really is doing is the second line there, the recency equals recip, and then a whole bunch of other things. Okay, that is using a reciprocal function, and I think at this point, let's go ahead and visualize that a little bit. So it makes more sense. And this is one of the lessons I've learned in Solr, that sometimes you just need to pop open an Excel doc and fool around with some of these functions and see what they do, graph them out. You know, this chart actually in Google Docs took me about 3 minutes to make. So the red line is the out of the box. If you Google for Solr date boost, the formula they give you is the red line, okay? And so notice that at 0 days old, you get a 1, and then it gradually falls off from there. The orange line is if I change some of the parameters to 5, you can basically flatten that out, which means your penalty for being an older doc is actually a lot less, okay? So, and this is 1 year of time. There are a couple others here that are interesting, I think, and we'll talk about the blue first, which is the one I gave in the example, right? You can see that example there. So the blue line, what it does is it really starts to drop quickly for as the documents get old. So we hit about the halfway mark within about a month and a half. Drops off very quickly to the boost being about half of what it would be if you just use relevancy by itself. And that was just actually tweaking these parameters here, the last two, 0.8 and 0.5. Okay, and then the last one is even more aggressive, and you can see I've configured it to drop off very quickly. So that's how this function here. So that's essentially the visualization of what you see on that first line. And there's some exotic syntax in there. The boost basically tells Solr that we're going to use a function query called Recency to boost our query, which is the query this user typed in wine. Okay. The one thing, did they talk at all about eDismax or Dismax in training? I imagine. Okay. So eDismax is a new one for Solr 3.1. And the difference between eDismax, and so if you can use it, especially if you're doing this, use it because its boost parameter, it actually is a multiplier on the relevancy score, whereas Dismax has a BF parameter, and that gets added to the relevancy score, and it just doesn't work when you add most of the time, especially for the date thing, because as you saw, it sort of starts at 1, or it can start a little higher than 1 and ramp down very quickly. That works better as a multiplier. Okay, so eDismax fixes that problem, and it also kind of makes it a lot simpler. You just say what my query is and then what the boost is on that. And again, I'm still using the reciprocal function. Notice in there that I'm also using the millisecond function, ms. And it looks confusing because it looks like I'm sort of dividing the current timestamp by the hour. That's not technically what it's doing. What it does is it kind of rounds the current timestamp down to the closest hour, and then it subtracts the pub date, so it gets how old that document is within sort of hour precision. And the one lesson there is actually that helps things a lot less memory in the index and things to be a lot faster if you can essentially calculate without exact millisecond precision. So here's some tips and tricks on this. So first one is, I mentioned it should be treated sort of as a multiplier on the relevancy score. That was a good lesson we learned. The boost syntax there, one thing we learned that sort of hung us up is that you actually, if you're using spell checking with boost functions like this, you actually do have to use the spell check Q parameter, which tells the spell checker exactly what you want it to spell check. Okay, so in this case, wine. If I was just to get rid of that and do boost on wine, like my previous example, you would actually get back in the spell checker results. It would try to suggest a spelling for boost and those kind of things, and some funny ones came up like roast and things like that. You can also bottom out the penalty. And that's the min function that I mentioned. So in this case, in this example, I'm bottoming out the penalty for being an old document to point to. And that's so that depending on your requirements, you may not want to actually remove really, really old documents. They would fall so far down if you let some of those other functions that I showed you, the steep ones, play without a minimum. You could, remove documents. And as I mentioned, not a one-size-fits-all solution. So this is where it would probably be another whole 50-minute session to talk actually about whether or not you should apply this boost. Okay, and so I think it's up to you to decide right now, based on your requirements, when it would be applied. There are, and I have the notes in the presentation here, a number of academic researchers that are focused on this problem, especially in terms of web, and they're mainly focused on when do we apply this boost, right? So this is how to apply it. The question of when depends on, essentially learning and analyzing logs and all those kind of things, because it's not always, depending on your content, an applicable boost to apply. Okay, so now we've sort of tackled the boost by date. I'd like to turn to our focus to boost by popularity. And the reason I wanted to introduce this is because I think we all get that the users out there, people that are familiar with Google and Facebook and things, they get the concept of sort of the herd mentality, and they get the concept of popularity. Oh, all my friends like this, I'm interested in it. So I think it's something that, again, it's a tool to have in your tool belt with Solr. So let's talk about it. Again, I don't think it's always you apply the popularity boost, and I actually think it does compete a little bit with the age boost. So you might want to decide one or the other, because it's perfectly reasonable for an old YouTube video, right, to all of a sudden be really, really popular for whatever reason. So if you apply the age boost, you may be kind of canceling out your popularity boost. The way I look at popularity is it's really mostly based on the number of unique views a document has. And the key thing with popularity boost as opposed to the document age is that we don't know what its popularity is at indexing time. Right? You can't just say, oh, this document is this popular. At least typically you don't know that. And so we're gonna see how in Solr do we incorporate a calculation, how we incorporate a calculation that is not known at indexing time still into the scoring. But first, let's kind of get a sense visually of how this might work. So if you look at that graph, kind of notice the document B there. Over a month ago, it was pretty popular, and then it sort of started ramping down, right? And the recent number of views is pretty low, especially compared to the other documents there. And then document C, well, it's sort of been stable over time, so it's pretty popular, right? And then document A just came on the scene last week, but it's got a lot of views, right? So people are really interested in document A. So this is kind of how you have to keep your mind around popularity, is that it's based on number of views in a time slot. So you had a document that was really popular 3 years ago. Well, you probably shouldn't keep showing that as popular because it's ramped down like B here. And again, you also kind of want to boost up things that are getting a lot of interest on your site, like document A. So that's how we kind of have to score popularity. Now, I would be surprised if the Solr external file field came up in training this week. Did it? Does that look familiar to anybody? Okay, good. So we're learning something new here. What this does is this tells Solr that you have data that will be used in queries and ranking and sorting that is not in the index. Okay, so the Solr guys have thought through this, and they came up with this thing called the external file field. Okay. The key is right now in Solr, it is only float types are supported, and that's for good reason, because they're kind of, float is a good field for scores, and that's really what we're doing here. So my external popularity score comes from an external file, is what I'm telling it here. And it will be keyed in that file by ID. So that's how Solr is going to, at runtime, make sense of the values in my file. Okay? So that's what you have to do on the indexing side in schema.xml to pull scores in. So let's kind of look at this from a high level, and then we'll dig in. So basically, user activity gets logged in probably a database if you're maybe a smaller site or internal type system, or if you're out on the web, it could be in just your web logs. And we'll talk a little bit about how those get processed. We have this view counting job, and it's sort of anonymous. We'll talk a little bit more about some of the details of that. But it goes out, it reads the logs, and it does a big counting problem. Okay? Remember, in the time slots, we had past, recent, last week, that kind of thing. So it counts up all the views of all your documents and how many times A was viewed in the recent. And this job has to run often. Okay? And it's up for you to decide how often that is. Is it every hour? You have a really dynamic site, or is it every day? So that's to be determined, but it will need to run often and in the background. Okay? It does its thing, and out comes a file of this format. So just keeping with my previous example, so A has a popularity score, which is the highest in this example. B is a little bit less than the other two, and C is kind of in the middle. That is reflective of what we saw in the graph. Okay, so it's just a flat file that this job writes. I've put where it needs to go. So it needs to go into your data directory because Solr is expecting to find, if you'll remember, when I indexed, I called it popularity. It is expecting to find this file. After this file is written, you have to actually send a commit to the Solr server. And that tells Solr, okay, go out and if there's new docs, obviously they'll commit those, but it will also go and pull this file and refresh it. Okay? So it pulls that new data in, and now you can do things like ranking, boosting, that sort of thing. Okay, so popularity tips and tricks. Anybody familiar, or everybody's probably familiar at this time with the concept of MapReduce? Is that people? Okay, few hands, okay. So MapReduce was a technique and supporting technology invented by Google, but now used by many, many big, large web properties, such as Facebook, Yahoo. MapReduce is a way, and it's perfectly suited for counting problems. So I'll give you the example of Facebook. They have terabytes, and probably right now it's close to 20 terabytes of log data a day coming into Facebook. They use MapReduce and a technology called Hadoop to process those logs to do things actually like calculate popularity and those type of questions that are very large counting problems that need to be executed day after day after day. Okay? And actually, Facebook invented a technology called Hive, which provides sort of a SQL-like high-level interface above MapReduce and Hadoop for doing things just like this. Give me the number of views in a time period and those kind of things. So one thing, if you have a lot of log data and a lot of documents that people are viewing constantly, you may want to look at like a MapReduce for doing this counting problem. If you only have a few servers and you can pull the logs in and process them with SQL or whatever, that's just as great too. So definitely something to look into for analyzing your logs. The other thing we've learned about popularity is that you don't ever want it to be less than 1 because a new document isn't popular, so you don't want to penalize it for. So it's always going to be sort of a multiplier on your relevancy score of 1 or more. We go up to 2 because just for what our requirements were is that we didn't want this to kind of overpower the popularity, but we kind of wanted to give it just a little bit of a boost around the popularity score. And then lastly, the spell checker can be configured to rebuild itself every time you commit. which sometimes that's a good thing. It's a little aggressive for really big sites, but if you have that set and your popularity job is in the background committing, all the time, new popularity scores, it's going to take a really, really, really long time to commit every time. So it's something just to keep in mind that this does have an impact of other components in your search solution, and spell checker is one of them. So the thing we found is that we actually had to turn that off and control both of them a little bit more manually, which you can do. This is kind of the build on commit for this spell checker is built in kind of for easy getting started, nice out of the box solution, but you'll want to turn that off, especially as your index gets really, really big. We've sort of covered document age and boosting that, and boosting by popularity. The last area is a little bit of divergence from boosting, is a solution we came up with, and it may not even apply to you, but it does highlight some of the things you can do with Solr that I think are just good to have in the back of your mind as being possible and actually very easy to do. So the magazine site that I mentioned had the problem of it gave users the ability to fine-tune their experience quite a bit. Behind the scenes, it basically pulled thousands of feeds, and blogs, news feeds, magazine feeds, that sort of thing. And it classified articles coming in into different categories and that sort of thing. Most people aren't interested in every possible category out there, so we give them the ability to turn off a bunch of categories. And then if you add a blog, if somebody adds a blog, we don't want everybody to see that blog because it's just a personal, somebody was interested in that blog. So it's a very similar solution technically to Google News, but it was more focused on magazine content. We allowed people to come in and turn on and turn off the feeds themselves. So the problem we had was potentially a user turning off thousands of feeds, and hundreds of categories and that type of thing. So it was just basically too many things to pass on the query string every time. So what we decided was that we needed a custom search component. And so one of the things that Solr is very good at is allowing you to easily kind of plug in to its built-in behavior, your own custom logic. And that's a lot of times done through a custom search component. And another example of a search component could be like spell checker, right? That's just a search component that can be pulled into the DisMax handler or the standard handler. You can write your own custom search component. And in our case, it was a search component that needed a connection to a database because we had to go out, do a bunch of queries to figure out which feeds were turned on, which categories were turned off, that sort of thing for our users. So that's kind of what we were faced with. The preferences component that we built connects to a database and essentially builds up a doc ID set. This is an internal Solr object, probably actually maps to a Lucene object that is essentially a big bit set. For all your documents, it says, is the document included or is it excluded? So a 0, 1 for all your documents. So if you have hundreds of millions of documents, you're going to have one of these for every user. So this is something you'll have to figure in to the calculation of, is this something you can accommodate for the size of your indexes, right? Again, it's 1 bit for every document. So you're going to have to get quite a few documents before you ever really run into memory. So, and that also you have to kind of calculate in how many users concurrently and those type of things. But bottom line, this doc ID set is held for each sort of active user, and it's stored in this LRU cache. The LRU cache is least recently used, so older stuff kind of gets thrown out of the cache in favor of newer things as the cache fills up. In my Solr config.xml, this is how you define a search component. It's very easy. You provide a class. Obviously, it has to be found on the class path for Solr, and you give it a name. And in my case, it's pref, and we'll see how that comes into play. And quite simply, the configuration parameter is I need a JNDI lookup for my data source for getting to the database. So the search component's job is to eventually pass the parameters on to a filter, in my case. So the two parameters we found useful were, one, the ID, which user are we looking at, and the other is, when did that user's preferences change? Because we need to know if their preferences change, we have to clear our cache. Behind the scenes, our filter goes out to execute some SQL against the database, and it essentially comes up with a list of disabled categories, feeds, and types for this user. Behind the scenes, Lucene has a concept of a field cache. And I'm hoping this came up in training, but a field cache is essentially all the values for each document for a particular field. Right? So it's a quick lookup. So if you remember back, my pub date, a field cache will be created in the Lucene index that will give me the pub date for document A very, very quickly. So in our case, we had one for category, source, and type, and we use this to basically go in and say, let's turn off, or we'll decide if a document is enabled by looking at these different fields in the index, category, source, and type. Now you could just include these as sort of filters in the query, but as I mentioned, there could be hundreds and thousands of feeds turned off. Those get to be really long and gruesome queries, so we decided, again, build it into a search component. In my case, we took the search component, the pref search component, and put it into the edismax search handler as sort of one of the last components. So let's see kind of how that works. So again, a user comes in and in our site updates their preferences, and potentially adding a new feed or turning a couple off. Then at a later date, after they update their preferences, they issue a query to Solr. They want to get some content now. So the query must be passed with two things for this preferences filter to work. So we pass 1, 2, 3. That's presumably this user's ID in the database. It's opaque to Solr. It gets passed on through. And then the mod is just the timestamp of when the preferences were updated. Okay. Solr, based on that search component configuration, knows to pass, because my component was called pref, it knows to pass those parameters on to my preferences component. Okay. The first thing the preferences component has to do is to consult the cache, right? Because we don't want to be going to the database on every query. That would kill performance. The happy users at the beginning on the first slide would not be happy. But we know that the preferences were just updated, so the cache is basically going to be out of date. So in which case, we now go back to the database and compute whatever it is we need to do. In my case, it was actually excluded category, sources, and types. And we then do filtering based off of that information and put it back into the cache. So that gives you an idea of basically you can customize, add your own search component, pass search component specific query parameters to Solr. It'll then direct them into your component. Again, you want to consider caching because, again, don't want to go to the database every time. The LRU cache, that is built into Solr. You don't actually have to write your own cache or anything. There's a nice API to interact with it and put things in and out and that kind of thing. What you do have to do, obviously, is figure out a way, is the cache dirty? And in my case, I use this simple, whenever it gets an update, I send a new timestamp across. That gets sent with every query. Most of the time, it pulls from cache because users don't sit there and update their preferences day in, day out. So to wrap up, the first thing we kind of learned is that, one, Solr has a lot of power built in with function queries to do boosting. And we saw boosting recent documents using the reciprocal function and the MS. The one thing we learned there I want to get across is that you typically will want to use something like an Excel or an online Google Doc to play with these functions, to see how they behave, chart them out, and see what makes the sense. In my case, I wanted documents to actually be heavily penalized and ramp down very quickly, so I worked with the recip parameters. For popularity, we learned that Solr has the ability built in to load data that's computed outside the index whenever you need it, and we use the external file field to load popularity scores. Popularity scores need to be built in some sort of cron job, right? It runs hourly, daily, what have you, and a good way to do that for large scale is through MapReduce and Hadoop, which I think there are going to be some sessions this week actually on big data search, and they'll probably talk a lot more about Hadoop and MapReduce. And then lastly, kind of showed you an example, not so much because it's a specific use case you might have, but to understand that Solr makes it pretty easy to pull in a search component, custom search component that you can use its cache and do things like filtering based off of user preferences. So what I'll do now is open up the floor for questions. So the question is, how do we take advantage of more dynamic preferences information than build the dynamic preferences? Okay, gotcha. So how to build dynamic preferences as the user is essentially using your search app. I would sort of say that's kind of a machine learning type analysis. And I don't know that you would actually get a lot of actionable sort of things you can really affect the scores and things of documents with by looking at a single user session. So you may, again, I think you may have to sort of track that behavior, because one search you're not going to learn that much. Maybe 10 searches you can, but the reason I think it's more of a machine learning problem is because you'll still have to relate that particular user session to other user sessions. And so kind of trying to find, well, what are the other users that had similar behavior, and kind of make action on that. I think where it may apply here is in the sense that you can have another concept of like an external file field, which is this computed score that you can solve. And maybe, again, the job behind the scenes, the machine learning job, would run potentially, more often than the popularity job or whatever. But I think you can use something like that. But my sense tells me you would have to somehow first relate that user's behavior with other users, and then decide there's ways of doing that, predicting what they might want or whatever, and influencing the score that way in the machine learning field. So I'm not sure that exactly answers your question, but I think it at least gives you a frame of reference to start thinking about it. So the question is, sort of when does the search component, when in the Solr processing chain does the search component apply? And the specific question around that is performance and scalability with large document sets. So as far as I know, it actually, from what I know, it looks at the entire doc set, right? Because and it may be how you configure where the search component comes in, but the idea is that a lot of these search components will have the deciding factor if that's actually a document that needs to be included, right? So I don't think it can always be just a post-process. Like the spell checker, I think can be a post-process, but as far as I know, it has to look at the entire doc set. So the area where, again, you are going to have a doc ID set for the entire corpus, and it's a 1 or 0 for each one in the case of filtering. So in that regard, you're dealing with memory. The compute time is very, very fast because it's just the doc ID set is very optimized and that sort of thing. So your real concern there is memory, which at least in the size of indexes that I've dealt with, memory's still the cheapest way to go about dealing with those type of things. So, but again, because you have to get a pretty big doc set before you start having an impact on memory when you're dealing with indexes. With search servers that have like 64 gig of RAM or something. Things like that. It takes quite a large doc set. So, but I do think it has to consult the whole document set as part of its part of Solr's decision making process there. The question is, does this work in a sharded environment? And the answer is yes, because again, Solr has to kind of consult all the shards and then come back with a final decision. Yeah, so it definitely does work. Oh, I'm sorry. There is someone at the...
That's why the microphone is
yeah,
for.
I know. Yeah.
I'm Georgi Moreshan from Glassdoor.com. I haven't used Solr. I've used Lucene. And these functions from Solr seem quite simplistic. And I don't see a big advantage. I can write that kind of decay functions myself. The problems that I have, and I wonder if you have experience with, is knowing what works, what parameters you should put. If you put 0.8 or 0.6, there is a big difference. And if you look at the 5, 6, 10 results, 100 results, you can estimate what you want. But then you put it in production, and people won't click on your results, or they may click. So do you have any experience with looking at what people click on and adjusting the weights accordingly, continuously, so that you optimize those values?
Right. So I think there's two things there. There is you do have to decide what works conceptually for your problem, for your search problem, and that's where you get close. And I showed you the graph, so that gets you close. And then there is the second thing: is you've put it in production, it's potentially not performing well. First, you have to decide how do you know it's not performing well, and some of the easy ones are analytics to tell most people are getting to the second, third, and fourth pages of your results, right? And they're not clicking on that first page of results. So I think you can use those analytics to decide that really relevant documents are getting pushed down too far just because they're a little older or whatever. So the experience I have in that area is basically looking at logs, our search logs, and also the tracking of clicks, so the click-through. And I think there are some sessions that actually look at click-through behavior on search results and fine-tuning for that. But you're absolutely right. You do have to take a step back and look and see. Again, like I said, if you are penalizing documents for their age too much, you can put in the min or what have you, and adjusting those parameters. So I think the lesson here is that Solr makes it easy to adjust those. Finding the exact adjustments you need is a work in progress, and you have to analyze it.
I think this is related to the first question, because you want at the same time to look into user preferences and recency and maybe other boosting for for the source or other things. So you have to weigh all these weights and decide which combination is the best. Thank you.
Yep. That's a good point. Sorry, there's a question here. So the question is where to find more information about the external file fields and customizing Solr with search components. First thing, I will post this. It'll be up within a week, and then I will also include the source code on my blog for this. I'll actually ask the Lucid folks if there's a place, because I think they're using some sort of online file sharing, that I can give the source code for that. I do know there's actually some pretty interesting... Oh, okay, great. Thank you. That was easy. So there's some pretty interesting ones related to not popularity, but using external file fields. If you kind of just Google out for that, I think you'll find it. And then custom search components. To be honest, I kind of learned that by looking at the code and actually looking at the code of other custom search components. So that's probably your best right now. I'm not sure where the wiki stands on that. I'm sure there's probably some examples of it, because it's a pretty common thing. So, but I'll definitely give the source code of everything I've done here for you. So, I think I have time for one last question, and then we're a little over. That's an interesting question. So the question is, instead of the external file field, can you use another index? I suppose you can. You would still need something to kind of trigger Solr to go out and execute a query to that other index, is my sense. But I've not seen the problem tackled that way, but I think it's something to research. But I don't know personally myself. So, okay. Well, thanks for your time, everybody. So I hope you came away with a few things you didn't know. And so I'm available. I'll be around the conference the whole time, and then you can email me, and I will be posting the slides and source code to the Lucid site. So, thank you.